Hello and welcome back to DIY Newbie to Pro. We had a near disaster here on our motor coach, and that's what the topic of this video is. We had replaced our Sharp microwave oven. It's a convection oven and it had failed. And when I replaced it, I noticed that in the back where it plugs in this cabinet, there's an electrical outlet that looks like this, and there was a crack in it on the surface. And it didn't really mean much to me at that point in time, so I kind of ignored it, which was my mistake. So we plugged the convection microwave into the outlet and we used it for a couple of days. And we did a heavy roasting on it one evening for dinner. And after dinner, I noticed that the displays on the LED for the oven weren't coming on. And so I trying to figure out what was going on, and I looked inside the cabinet here where it plugged in. And the outlet had melted, as you can see, and the plug itself melted down where it got so hot. And the reason why that occurred was because the way these are designed, they are very, very poor. And I don't even know why the manufacturers put this style in. It's designed to use without a box, so it's self-contained. And the wires just fit into notches here. They don't screw in like a regular outlet does, and I'll show you that in a second. So when you put your wires in and you compress this, the wires go down into the grooves, and that's what forms the connection. And as you can see, all of the connections are in the plastic, and so if that plastic gets cracked on the outside, those connections where your plug goes in and touches it are going to have a gap, and that causes resistance because you don't have full contact. And when you have that gap in the full resistance, it creates heat, because electricity with resistance creates heat. And that heat will get hot enough to do this, to melt the unit inside and out, as you can see the back of it. And we are really, really lucky that that didn't catch on fire, because that would have been inside the wooden cabinet and the wall. And who knows how far it would have gotten. Fortunately, we do have a fire extinguisher, but we didn't have to use it. I have two kinds of boxes. I have a metal box and a plastic box. Both are used in homes. And so when you have an outlet, the one that I bought that I'm going to replace it with is one that you can put the wires straight in, and then you tighten the screw and it clamps down onto it. You can also take it and wrap it around the screw and turn it as a terminal. Inside the cabinet, the wires were too short, so I don't really have enough room to wrap the wire and to attach it to the terminals. So I'm going to stick them inside the gaps and screw down the screws, which will hold it in tight and be firm. And I'm going to use a metal box. I just brought the different ones out to show you the different kinds. I don't have much space in there. So I'm going to attach this box into the wall with some screws, bring the wire through the back, and put the duplex outlet inside the metal box, and then put my cover on, and we'll repair it with a good solid system instead of using this flimsy plastic that, as I said, once it cracks. If you see an outlet in your RV that's cracked, you need to replace that immediately, because this is the end result. And once again, I don't know why the manufacturers do that. You can even see a crack in the back of it. And the reason they crack is over years of fatigue, heat, and so forth, because they're inside a sealed cabinet, or they just, because of transportation, when you're driving them, the movement over time can force them to crack, and the plastic gets brittled over time. This unit was back inside here, and you can see where it was inside the back of the wall, and this is the cord that goes through that plugs into the Sharp microwave convection oven, and these are the wires that I have to work with. So I have a black, a white, and a ground. So you have the load, the neutral, and then the ground, and that's how we're going to attach it when we go. So we're going to put one of these boxes in that wall. We're going to take it and screw it in so it's mounted, and I got a box that has wings on it, so those wings can hold that in, and then with screws. And then I'll pull the wire through and mount that in, and will be repaired. And then I have to replace this also, because that's melted, and that'll cause a problem again, because once again you don't have good conductivity of the wires connected to the prongs. So I'll have to cut that off and repair that also. The wire to come through the box, and looking at where this is inside, it's on the lower section. So I'll take the lower one out. You just put your screwdriver in to pry it out. Then take your pair of pliers, needle nose, grab the edge, and you're just going to twist it till it comes out. So that's where the wire is going to come into the box. And you discard this because you don't need it, and discard this because you don't need it. Next thing we're going to do is put the box in and see where I'm going to drill some pilot holes to mount it so that I can then screw it in through the pilot holes. Stuck the metal box in the wall. I haven't screwed it in yet. I put the wire through where the hole was I pulled out. I've taped up the wire where the notches were, where the insulation was damaged because it's too short for me to patch. And so the next step is I'm going to do some pilot holes so that I can drill into the back wall to hold the box in. You can notice it's off center a little bit. That's okay. I can also move it over a little bit if I need to, probably just like that. So I'm going to drill 2 holes in this upper one and this lower one, and then I'll just put screws in there to hold it in. I've drilled 2 pilot holes, one in the upper corner, one in the lower corner, and now I'm just going to put my cordless in there and screw it in. This one side's going through some metal, so that'll act as a good holder, and it'll bind that pretty well. So that one took a good bite. The one on the other side is not going through any metal, so it's going to be a little bit looser. So you want to make sure you don't strip the screw in the backing, so you get the bite. So we're going to put that in too. Okay, so now we have our box attached. The next step is going to be to take the ends of these wires and strip them off a little bit so that I can put the outlet in and tighten that down. Now I have to prepare the outlet to put in. I did strip the wires, and there's a little strip gauge on the back of your outlet as far as how far to strip it. I'm going to put the outlet in this way because the wires are coming out of the box there, and that's the closest place to get to the ground wire. So I'm going to use these terminals, which means the other terminals that I'm not going to use, I have to tighten down. You can use either a Phillips head on this one or a little square drive, which is what I'm using. So you can put that tight. And same with the other one over here. If you're not going to use it, make sure you tighten it down so there's no arcing or shorting as things vibrate and go. And now those 2 are tight, so I'm going to put the white in the silver, and the gold is going to be the black. So just remember, color goes to color, and the silver is the white, so that one's going to go in that side. So what I did was I stuck the wires in the back of the slots, and I tightened down the screws on each side. It's very difficult because it's a tight, confined space. Make sure I had the right color on the right side. And then in the back over here, there's a ground wire, and I ran that wire into the onto the screw, and I bent it around it, and then I tightened that one down. I have the outlet installed. There's 2 screws that mount it to the box, electrical box I put in. One on the left, one on the right, and it's firmed in. Nothing seems to be shorting around, so it looks good as a good installation. So the next thing we're going to do is put the cover over it, and then I'll go out and turn the circuit breaker back on. Remember, before you ever work on something, turn the circuit breaker off. Okay, I went outside to my inverter and turned the circuit breaker on, so now that circuit is live, and I put my faceplate on. So now I have a voltage checker. It'll make sure my current is good in there and that I have no broken wires. So I'm going to put that on. I plug it in, and it shows me that I have 120 volts in that side, so that one's good. Now let's try this one, and that one shows me I have 120 volts also. If you don't feel comfortable replacing it, then just hire an electrician or a RV repair tech and have them do it, because it's worth spending the money versus having something burn down on you. And as you can see, they do catch on fire and they do melt. So the next step is to get everything back to normal is to replace this cord. So what I'm going to do is cut the cord off, strip the wires, and I have a new plug to put on, and then we'll plug that in and make sure you have it wired correctly, and then test the appliance. This is the plug that I'm going to replace it with, and as you can see, it has a hole in the back where you're going to feed the wire through. I loosened the 3 screws so I can pull it apart. Inside you have a green, which is this one, which will be your ground. And then the same connections that you had before. There's a gold and a silver. So we're going to, on the gold we're going to put the black, on the silver we're going to put the white, and on the green we're going to put the ground, which will have no insulation. And then we'll reassemble it. So you have to put this over the cord first, and then you attach your wires to it like that. Then you push it through and tighten everything down and tighten the clamps. I have my wires stripped and the insulation off, and I separated them. And I have my white, my black, and my green. I have my cover of my outlet pushed through the wire. I didn't have to take the center out, it just slid on okay. And I loosened up my connectors here because you're going to put the wires in the gap between the two metal plates. Then you're going to screw down the wire. So we're going to start with the green, and you can just line them up correctly, or start with whichever one you want. Make sure that your strands of your wire are twisted so they all go underneath the plate. You don't want to have a couple stragglers because that's not good. You want to have as much wire as you can underneath it. So on the silver one's going to be the black, the gold one's going to be the black. So you just stick that in as I did. And then you're going to take your screwdriver and go in the slot. And I'm using a square drive again just because the screws are square drive and it strips less. I'm going to go back and tighten them in a minute. I'm just putting them in now snugly. Take the ground one and put that in and do the same thing. And get it snug. And then do your white. And just put it down so it fits in. That one came unraveled a little bit. So we're going to twist it around so it's tight again. You want a good connection. Then stick that in. And then hold it. And then bring it snug. And then we'll go back and make sure that when we snug everything down, that the insulation is not in that metal. The insulation is resting on top. You should see just a little bit of wire on each. And that should slide in like that. And now we'll take our screws that hold it in and put them in. And that is a Phillips head, so we have to switch from the square drive to the Phillips head. Alright, we have all three screws in, so the plug's back together there. Now you want to put the cable clamp on so that it keeps the cable from being pulled out, because you never pull a cord out by the cable, you always pull out by the plug, but this prevents, if you do pull it out by the cable, it'll keep it from pulling the connectors out of the outlet clamps. So you're going to snug this down until it's snug and do it balanced so it's even on each side. And then once this is done, we can plug it in. We already know the outlet's good, so we can plug this in and test the convection microwave and make sure that that's up and running correctly. And remember, when you test the microwave, you don't want to test it empty. You always want to put a glass of water or a bowl of water inside of it to make sure. Okay, that's snug. That looks good. So now we can plug this back into the outlet and put our cabinet back together again. Power back on. It seems to be functioning. We have, I'm not going to turn it on, but we have power to the microwave. It's charged up again. And so that repair is done. And remember, if you see a crack in an outlet faceplate or in the receptacle, make sure you turn the circuit breaker off and don't use it. Get it replaced. If you don't feel comfortable replacing it yourself, then hire an electrician or an RV repair tech to do that, because this could lead to a major fire and you could lose everything in your RV, including your life. So it's very important to do that. And this was not done by any fault of human error. It wasn't done by overloading the electrical supply with the microwave oven. This is a 15 amp circuit. Everything here was rated at 15 amps. It was because of the fact that the faceplate cracked and it failed, which allowed the contacts not to have full contact onto your cord, which caused resistance in the electrical flow, which caused the heat, which then caused the damage. Please, on the bottom of our screen, hit the like button and subscribe, because the reason why you subscribe is you never know what we're going to get into next. Believe me, in the RV life, it's always something. Thank you, and we'll see you next time. Bye.